To understand a topic fully, it's important to understand the basics. So we must begin with the first question. What is a computer? At its core, a computer is simply a calculator that works automatically. Instead of typing numbers and commands on a keypad, the user creates a program full of instructions, and the computer carries them out in sequence. Despite the advances of modern computers, they're still nothing more than simple adding machines. The key difference is speed. A modern computer can carry out millions or even billions of operations in a single second, making the most mundane tasks incredibly simple. A modern computer consists of two core components, a processor and memory. The processor carries out arithmetic operations, that is, addition, subtraction, multiplication and division, and logical operations, that is, comparisons between two values to produce a new value, the most typical being AND, OR, and exclusive OR. The memory is used to save both the program and the results. Computers vary in complexity, but all have these two fundamental elements. In order to communicate with the computer, input devices are used. These include keyboards, mice, joysticks, and so on. For the computer to communicate with us, there are output devices. Monitors and TVs are the most obvious, but most computers have sound devices as well. All of these, including the computer itself, are called hardware, while the programs and data used by the computer are called software. So how precisely does a computer work? The first key concept to understand is what input a computer takes and how it receives it. Humans use a system known as decimal, or base 10, probably because we have 10 fingers. What this means is that we count up until we reach the 10th digit, in which case we add 1 to the next digit and return the first digit to 0. The second digit also continues in this way, as does the third, and so on. Computers don't think like this at all. They rely on a series of electrical impulses, which either have a charge or don't. This state of being on or off is represented in text form as binary, or base 2. Unlike base 10, we count until reaching 2, then add to the second digit and return the first to 0. In computing, each of these ones and zeros is known as a binary digit, or bit. Seeing a continuous series of ones and zeros would be impossible for a human to understand, so the convention is to group 8 of them together to form bytes. A binary number that has 8 bits has a maximum value of 255. This is rather awkward, so instead of decimal, base 10, we use hexadecimal, base 16. In this system, instead of adding to the next digit when reaching 10, we do so when reaching 16, by going from 0 to 9, then A to F. This means 255 is written as FF, but it gets even better. In base 16, each bit can be calculated in a simpler way. 10, 20, 40, and 80 is easier to count than the decimal alternative. You can think of each 4 bits as one hexadecimal digit. So we generally read computer memory in hexadecimal, while the computer reads it in binary. So does a computer read every single bit individually? Actually, no. The Central Processing Unit, or CPU, has a number of pins, and it uses some of them to take in the bits of information. This transfer of bits is known as a bit stream, and the system of delivering the bit stream is known as a bus. Older CPUs, such as that used in the NES, have an 8-bit data bus, so they read 8 bits at once. Similarly, the CPU in the Genesis or Mega Drive reads 16 bits at once. This is one reason why the processors, and by extension the consoles themselves, are known as 8 or 16-bit, but this also has as much to do with marketing as anything else. In addition to the data bus, the CPU also has an address bus. This is used by the computer to know where to find the data that the data bus needs to access. As already mentioned, the NES has an 8-bit data bus, but it also has a 16-bit address bus. This means it can address memory up to a maximum of 16 bits, or FFFF in hexadecimal. Remember that 4 bits are equal to 1 hexadecimal digit. 10,000 hexadecimal bytes is equal to 65,536 decimal bytes, or 64 kilobytes. So we know how the processor receives data and how it processes it. The next question is where it gets this data from and where it is stored. For this, we need to understand the other key component of a computer, memory. the most important type of memory in a computer is random access memory, or RAM. It's called this because any part of the memory can be accessed at any time, unlike a cassette tape, for example. This is important because for a processor to read a program, that program must be kept somewhere that can be accessed instantly, such as RAM. Therefore, a program generally must be loaded into RAM from somewhere: a cassette tape, a floppy disk, an optical disk such as CD, DVD or Blu-ray, or from a hard disk. There is one more option, and this constitutes the other main type of memory: read-only memory, or ROM. As the name implies, the processor can only read this memory, not write to it. Other than that, it works just like RAM, in that it can be accessed randomly at any time. ROM is often used both inside computers to store such things as operating systems, and inside game cartridges. Video game consoles that use cartridges generally don't have a lot of internal RAM, because they can use the ROM inside the cartridges as a type of memory. Computers, and consoles that use optical discs, need a lot more memory, because anything that can be used must first be loaded into the internal RAM. So, to recap. Computers and consoles are automated calculators which can make calculations extremely quickly. We can communicate with them, and vice versa, and it has both a processor to do the calculations and memory to store the results. We know how they receive and process data, so the next stage of our learning is to understand what kind of data they receive. Next time, we will learn all about assembly and programming languages. See you then!